Greetings to all. This is Maulika, Assistant Professor, Department of Physics from St.Josephs College of Arts and Science for Women, Hosur. In this video, I am going to deliver about liquid rough model of atomic nucleus. We have three types of nuclear models. One is the liquid rough model, the second one is shell model, and the final one is collective model. In these three, I am going to discuss about only the liquid rough model. In this model, the forces acting in the nucleus are assumed to be analogical to the molecular forces in the droplet of some liquid. This model was proposed by Niels Bohr, and he found some similarities between the atomic nucleus and a liquid rough. The first similarity is about shape. The shape of the nucleus is supposed to be spherical in a stable state, just as a liquid drop is spherical due to symmetrical surface tension forces. The second similarity is surface tension. The force of surface tension acts on the surface of the liquid drop. Similarly, there is a potential barrier at the surface of the nucleus. The third one is density. The density of a liquid drop is independent of its volume, as well as the density of the nucleus also independent of its volume. The fourth similarity is force. The intermolecular forces in a liquid are very short range forces. We know that. Likewise, the molecule in a liquid drop interact only with their immediate neighbors. So, similarly, the nuclear forces are short range forces. Nucleons in the nucleus also interact only with their immediate neighbors. This leads to saturation in the nuclear force and a constant binding energy per nucleon. The final similarity is about splitting. When a small drop of liquid is allowed to oscillate, it breaks up into two smaller drops of equal size. The process of nuclear fission is similar, and the nucleus breaks up into two smaller nuclei. The liquid rough model can be used to get an expression for the binding energy of the nucleus. In this image shows the semi-empirical mass formula. This formula contains five terms. The A is the mass number and Z is the atomic number. We know that N is the number of neutrons present inside the nucleus. The first term is the volume energy. So, the larger the total number of the nucleons, the more difficult it will be remove the individual protons and neutrons from the nucleus. So, the binding energy is directly proportional to the total number of nucleons. The second term is surface energy. So, we know that in nucleons at the surface of the nucleus are not completely surrounded by the nucleons. Hence, energy of the nucleons on the surface is less than that in the interior. So, the number of the surface nucleons depends upon the surface of the nucleus. So, the negative energy, surface energy. So, it is most significant for the lighter nuclei since a greater fraction of the nucleons are on the surface. The third one is the electrostatic repulsion term. So this electrostatic repulsion between each pair of protons in a nucleus also contributes towards decreasing its binding energy. The fourth term is asymmetric term. The lack of symmetry between the number of protons and number of neutrons in the nucleus. If protons and neutrons is equal inside the nucleus, the stability of the nucleus is maximum. If not, the stability of the nucleus is decrease. The decrease in the binding energy arises from this is called the asymmetric energy. This is also negative. The final correction term del allows for the fact that even nuclei are more stable than odd nuclei. Del value is always positive for even nuclei, is negative for odd nuclei, and the del value is 0 for odd A. The second image shows the graphical representation of semi-empirical mass formula, or we can say Weizsäcker formula. With the help of this model, we can calculate the atomic mass, binding energy, alpha, beta, decay energy, and fusion energy of the nucleus. And the calculation of the atomic masses and binding energies can be done with good accuracy with the liquid draft model. And the disadvantage is this model fails to explain the other properties, in particular magic numbers, and it fails to explain about spin and magnetic moments of the nuclei. So this is about liquid draft model. Thank you.